Could everyone please turn on their cameras? All right. So my name is Aiden, and today I'll be teaching you all about recursive functions and recursion. I believe last class you went over number systems and prefix, infix, and postfix notation. And so today we'll be going over a brief algebra review of what functions are, and then recursive functions and how to use them. So what is a function? Function is just an equation that has only one answer for every input. And you can commonly see functions as f of x, g of x, h of x. They'll kind of look like that. And so here's an example of a function f of x, where f of x is equal to x plus 7. So if x was equal to 2, then the answer would be 9, since 2 plus 7 is equal to 9. So now that we know what a function is, what is a recursive function? A recursive function is any function that repeats or uses its own previous term to calculate the next terms and then forms a sequence of terms. So if f of 1 is equal to 1, and the function is that f of n is equal to f of n minus 1 plus 4, that would be a recursive function, since f of n is using n minus 1 to calculate what f of n is. And this is kind of the basic notation for a recursive function. Does anyone have any questions so far? All right. So here's an example sequence. And if you look at the sequence, you can see that every number is the number before it plus 5. And so out of that, we can find the recursive function f of n is equal to f of n minus 1 plus 5, where f of 1 is equal to 10, since that's the number we start with. So if we plug in 2 into f of n, we get that f of 2 is equal to f of 2 minus 1, which is 10, plus 5, which is 15, which is how we get the second number here. And then if we continue with 3, 4, 5, 6, and so on, you'll get all the rest of the numbers of the sequence. So this second sequence might be a little trickier to find a pattern. I mean, if anyone sees a pattern, you can shout it out. It's okay if no one knows what the pattern is, but essentially it's just each number is the number before it multiplied by 2 and then subtracted 2. So we see if f of 1 is equal to 3, which is the first number here, then the second number would be 3 times 2, which is 6, and then minus 2, which is 4. That's how we get that number. And so the recursive function for this sequence would look something like this, where f of n is equal to 2 times f of n minus 1, and this is the previous number, and then minus 2. So this is the Fibonacci sequence. And so for those of you who don't know, each number is just the two numbers before it added together. So we start with 0, f of 1 is equal to 0, f of 2 is equal to 1. And then that means that f of 3 is equal to f of 1 plus f of 2, which is 1, and it goes on. And you can kind of see the pattern I was talking about earlier in the function, where each number n is equal to the two numbers before it, so n minus 1 and n minus 2. So if you pay attention to the way these two statements are written, the difference you'll notice is that the correct statement has this thing at the top, which is called the base case. And so every recursive function has a base case, which kind of stops the function where it's at, so it doesn't repeat forever. And like the Fibonacci sequence, many functions have more than one base case. So for this one, f of 1 is equal to 0 and f of 2 is equal to 1. So how do we solve a recursive function? So say, for example, we're trying to find f of 5 for the Fibonacci sequence. So the first way we can solve a recursive function is called the top-down approach. And it's where we break the larger problem, so f of 5, into its two smaller components, which is f of n minus 1, 4, and then f of n minus 2, 3, as you can see here. And from f of 4, we can break that down further into 4 minus 1, which is 3, and then 4 minus 2, which is f of 2. And then continuing on, we can break down f of 3 into f of 2 and f of 1. And then from f of 2, we can break that down into the base case, which is f of 1 plus f of 0. And as you can see here, f of 1 is equal to 1, and f of 0 is equal to 0, which means that f of 2 is equal to 1. If f of 2 is equal to 1 and f of 1 is already equal to 1 from the base case, that means that f of 3 is equal to 2. And we can keep going back upwards. So f of 4 would be equal to 3. And that leaves us with f of 5 is equal to 5. All right, I'll slow down, sorry. And if anyone has any questions, you can ask in the chat or anything like that. So if you look at the top-down approach, you might think, like, why would you start from the top and then go down only to work back up? So this is the bottom-up approach. So since you know for Fibonacci what the two base cases are equal to, and you're trying to find f of 5, you can just start with the two base cases since you know their value. So f of 1 is 1 and f of 0 is 0. So then you can work back up the ladder. So you get f of 2 is equal to 1. And then f of 3, which is f of 1 plus f of 2, all the way back up to f of 5. And you will land back at f of 5 is equal to 5. And if these aren't clear yet, there's some practice problems later that I'll go over and show you both ways. So the top-down approach is the recursive problem-solving approach, and bottom-up is an iterative approach. But basically, the top-down sequence, you are breaking down the bigger question into the two smaller problems. And so it will take longer, but it is easier since you'll always be able to kind of figure out what the process is. With a bottom-up approach, it might be slightly trickier since you may not know how the function will get to the bigger question, sort of. And so using the top-down approach, I'll give you guys a few minutes and see if anyone can solve what f of 10 would be for this equation. And I'd recommend for this one to start with the top-down approach since it's easier to figure out what you're doing that way. It's okay if you didn't get the answer yet, but for the sake of time, I'll just explain how I did it. And for those of you saying 12, that is correct. And this is why. So if you look at f of 10, you'll notice that since x is equal to 10, it kind of qualifies for the first equation up here, which is f of 10 is equal to f of 10 minus 2, which is 8, and then plus 3. And so now you have to figure out what f of 8 is. And f of 8 still qualifies as the top equation. So we can continue with that. Equal to f of 8 minus 2, which is 6. And then plus 3. And then f of 6, since 6 is or does not qualify for the top equation anymore, we use the second one here, which is f of 6 minus 1, which is 5, and then minus 1. And f of 5 still counts as the middle equation, so f of 5 is equal to f of 5 minus 1, which is f of 4. And f of 4, once again, still is the middle equation. So you can continue that and get f of 3 minus 1. And finally, f of 3 qualifies for the bottom equation since it is equal to 3. So we get f of 3 is equal to 3 squared, which is 9. And so from there, we can work our way back up the ladder. Since f of 3 is equal to 9, we know that f of 4 is equal to f of 3 minus 1. And this is essentially equal to 8. And since f of 4 is 8, we can keep going back up. And f of 5, which is f of 4 minus 1, that means this is equal to 7. And once again, f of 6, which is f of 5 minus 1, is equal to 6. And then so since f of 6 is 6, then f of 8 is 6 plus 3, which is 9. And then that means that f of 10, which is f of 8 plus 3, is equal to 12, which is our final answer. Sorry. Here's another question for you guys to try, and I'll give you more time this time. So So it seems like a lot of people have gotten answers, so I'll go through this. So you want to think about f of 20 comma 12, which is x comma y, kind of as like one number, so to speak, like you're treating it as one term. And so if we look at this equation right here, 20 is greater than 12, which fulfills this requirement of x is greater than y. So we use the top equation for our first step. So 20 minus 3 would be 17. And then y, which is 12, plus 1 would be 13. Hopefully that first step made sense to everyone. So now we need to find what f of 17 comma 13 would be. And this still fulfills the first requirement since 17 is greater than 13. So once again, we'll stick with the first equation. So sorry, that's meant to be 14. So now if we look at it, 14 and 14, same number. So x is equal to y, which is how we get, so since x is equal to y, now we use the second equation, which is 2 times f of x plus 2, which is 16, and then y minus 3, which is 11. 1611 qualifies for the first equation again, so we're going back up to the top. And 16 minus 3 is 13, and 11 plus 1 is 12. And again, we use the top equation. So 13 equal to 13 minus 3, which is 10, and y plus 1, which is 13, plus 3. And finally now, since 10 is less than 13, we can use the bottom equation, which is our base case in this scenario. And so f of 10 comma 13 is equal to 10 plus 13, which is 23. And now once we have that, we can start working our way back up the ladder. So f of 13 comma 12 is f of 10 comma 13 plus 3, which is 23 plus 3, which is equal to 26. And now that we know that f of 13 comma 12 is 26, then the step up above that, which is f of 16 comma 11, is equal to 29. And then we can continue working our way back up the ladder. So the next step, which is f of 14 comma 14, is equal to 2 times f of 16 comma 11 down here, which is equal to 29. That would give us, and then minus 1, which would give us and then since f of 14 comma 14 is 57, get 60. And then finally, f of 20 comma 12, which is 60 plus 3, so 63. And this would be our final answer. So those of you who said 63 would be correct. And I hope that process made sense. If anyone has any questions, you can ask now. All right, so here's one more practice question you guys can try. And just know that this middle equation here, everything inside the bracket will return the greatest integer less than or equal to that number. So if you get, say, like 2.4 here, this would round out to just 2. It seems like a lot of people are getting answers, so I'll explain how I did this problem. All right, so this is similar to the question earlier where the equation used was different depending on the x value. So you're trying to find f of 20. And so x in this case is equal to 20, which means that since 20 is greater than 15, it fulfills the top equation here. So you get 2 times, so f of 20 is equal to 2 times f of 20 minus 3, which is 17, and then plus 1. So now that you have this equation, you need to find what f of 17 is. And 17 is still greater than 15, so you're still using this top equation up here. 17 minus 3, which is here, is equal to 14. So now that 14 is less than 15 and is in between 12 and 15, you use this second equation here. And just remember that these brackets here, if you read the bottom, it means that whatever you get inside of here is rounded down to the closest integer. So f of 14 equal to f of 14 plus 2, which is 16. And then that is divided by 3. So now we need to find what f of 16 is. Since 16 is greater than 15, once again, we go back up to the first equation. And 16 minus 3 is 13. Make this a little bigger. And then f of 13, once again, qualifies for this second equation. So we get f of 13 is equal to f of 13 plus 2, which is 15. And then divided by 3. And so now we have to figure out what f of 13 is, we have to figure out what f of 15 is, which brings us back up to the top. Then 15 minus 3 would be 12. And finally, we can get to the base case down here since x is finally less than or equal to 12. So we get f of 12 is equal to 2 times 12 minus 3, and 2 times 12 is 24 minus 3, which is equal to 21. And so now that we know what f of 12 is, we can figure out what f of 15 is since f of 12 is 21. So we get 2 times 21, which is equal to 22, or sorry, 42. And then we add 1 to get 43. And this is for f of 15. And so now when we go up here, you get f of 15 divided by 3. And I think this is where some people got a little confused. It's okay. And so 43 divided by 43 divided by 3 is not a whole number, but since we round down, we get 14. and then we go back up to this one. So f of 13 is equal to 14, which means that f of 16, which is 2 times f of 13 plus 1, is equal to 29. And so you can kind of see that we're using the base value we got at the bottom to kind of climb back up the ladder, since we know what, if we're trying to find, so for this one, we're trying to find f of 14, and we know that f of 16 is equal to 29. And so we just divide that by 3 and then round to the nearest whole number. And since f of 14 is equal to 9, f of 17 is equal to 2 times 9 plus 1, which is 19. And then finally, to get our final answer, you get that f of 20 is equal to 2 times 19 plus 1, which brings us to 39 as our final answer. And does anyone have any questions? If not, then we can continue to the next question. This one may look a little confusing since a lot of functions are inside, but just break it down into starting from the inside here with f of 20, find that, and then work on f of 20, and then continue until you get to the outside one. So it seems like a lot of people are getting their answers. And so I'll go through this one. And it might look slightly challenging since there's a lot of functions inside of the functions, but it's pretty straightforward. So for this one, you want to start with f of 20 on the very inside, since once you find that, you can continue to find the functions moving outwards. So f of 20, 20 is even. So this is the top equation. And 20 minus 2 is 18. And then 18 divided by 2 is 9. So f of 20 is equal to f of 9 minus 1. So now f of 9 is odd. So this is one of the base cases. So f of 9 is equal to 18, since 9 times 2 is 18. And so once you know that f of 9 is 18, that means that f of 20 is equal to 18 minus 1, which is 17. Okay, so now that you know that f of 20 is 17, you need to find f of 20. Or you can just write it as f of 17. And 17 is once again odd. So f of 17 is just equal to 17 times 2, which is 34. And now you need to find f of 17, and f of 17 is 34. So essentially, you're just looking for f of 34. And 34 is even, so that means we'll have to use the top equation one more time. And this one will give us 34 minus 2 is 32. 32 divided by 2 is 16. 1. I'll write it out completely just so it makes sense. Okay, so you know that this is 16. So you're looking for f of 16 now, and which once again is an even number. So 16 divided by 2 is 8, or minus 2, sorry, 17. Or sorry, 16 minus 2 is 14. Divided by 2 is 7. And so now you hit another base case, and 7 is odd. So f of 7 is essentially 14, going back up. So now that you know that f of 7 is 14, this means that f of 7 minus 1 is 13. And remember that f of 32 divided by 2 is 16. And since f of 16 is 13, this is 12. Since 13 minus 1 is 12. Oh, sorry, I think I missed something. Sorry, hold on. Okay, just so ignore this part. I missed one more function. Yeah, so f of 17 is 14. Or f of 7 is 14, sorry. So okay, so now we need to find the fourth and final function. So f of 14. Or wait, sorry. This is actually correct. So we find f of 34 is 12. And then once we find that, we can go, I'll draw an arrow. We can find f of f of f of f of 20, which is the question at the top. And so f of, go down. So this is, so we have f of 34, which is the second to last step. So that means that now all we're looking for is the f of 12. Right, so f of 12 is equal to f of 12, f of 10, or sorry, 12 minus 2, which is 10, divided by 2, which is 5. And then minus 1. And f of 5 is equal to 10, since this is the base case here. So finally, once we have that, we can find that f of 12 is equal to 10 minus 1, which is 9. And then since f of 12 is equal to 9, and this is the final, this lines up with that, our answer is 9. So this, essentially this function down here is just to find the very outside f, which is that one right there. And this one is kind of confusing since there are a lot of functions like layered in each other. But that's essentially it. And if anyone has any questions. I believe our time is almost up, but there are some challenge problems that we have. And if anyone wants to try and figure this one out quickly. So essentially just try and find a recursive function that can solve this problem. So our time is almost up, so I just want to briefly explain how I would solve this problem. So this time we can finally use the bottom-up approach since we know kind of like the two base cases. So if we have one step, as shown here, this is kind of our one base case since one step is equal to one way. And then with two steps, there are two ways to do it. So these are kind of our f of 1 is equal to 1 and f of 2 is equal to 2. Actually, I'll write that down. And then so if you look at this one here, which is essentially f of 3, you can kind of see that it's this first step stacked on top of the second step, sort of. And so there are kind of three ways that you can continue with this one. But essentially, if you think about this as being these two added together, you can kind of think of it as f of n is equal to f of n minus 1, which is this step right before it, since you're subtracting 1, and then plus f of n minus 2. Since this one is, if you think about it, this one's kind of the sum of the two combinations you can find in these two. We are over time, so that is it for today. I think there is one question that I wanted to get to, but I wasn't able to. But you can maybe try this for homework, and next class I'll go over it. But yeah, that's it for today. Thank you.